In this video, we are continuing section 2.4, and we are going to do an absolute value example. So let's sketch the graph of y equals absolute value of negative 3x squared plus 22x minus 7. So we have a quadratic function, but it's all inside of an absolute value. Okay, so to get this thing started, it would be helpful to know, well, what is the graph of y equals just the inside of the absolute value going to be? So negative 3 squared plus 22x minus 7. So if I were to get rid of the absolute value and graph that, well then graphing the thing with the absolute value is just going to be one quick extra step. Okay, so let's start with this. Alrighty, so this is a quadratic function. So, we know the graph is going to be a parabola. This leading coefficient is negative 3. That indicates to us that it's a downward facing parabola. Okay, but we're going to need to find the vertex and the intercepts to draw an accurate picture. Okay, so let's complete the square. So I got y equals, recall that when we have a leading coefficient that's not just 1, I first got to factor that out of just the first two terms. So the last term, the minus 7, that's going to stay outside. So when I factor out that negative 3 from the first term, I'm left with x squared. From the second term, well, 3 doesn't divide it perfectly. So the way we write the leftovers is we write what's there currently, which is plus 22x. And then we divide the thing that we just factored out, that negative 3. And we could check that if we wanted to. Like if I distribute it to the first term, I get negative 3x squared. If I distribute it to the second term, well, it's going to cancel that negative 3 on the bottom and leave me with the 22x, which is good. That's what I had before. Okay. All right. So, that's the first step of completing the square. I factor out that leading coefficient if there is one. So we got negative 3x squared. And then if I have a positive in front and a negative in the bottom, that just becomes a negative. So I got negative 22 over 3 and then x. All right, I'm going to leave some space here. And then I got the minus 7 at the end. And now let's do the whole thing where we, take the coefficient of x, we divide it by 2, and we square it. So let's take the negative 22 over 3, and let's divide it by 2 first. So all that divided by 2. So we get negative 22 over 3. And when we divide by 2, that's the same thing as multiplying by the reciprocal. So the reciprocal of 2 is 1/2. Okay, now that's nice because I could cancel a little bit both the 22 and the 2. I can divide them by 2. So I'll have an 11 up here left over and a 1 down there. So now multiplying, I'll get negative 11 over 3. Okay, so that's what I get when I divide that coefficient by 2. Now I got to square it. So negative 11 over 3, got to square that. So that's going to be 121 over 9. Okay, so I have to add that number, add 121 over 9, and subtract 121 over 9. And both of those need to happen inside of the parentheses, right? We talked about why that is in the last video. Okay, so the addition and subtraction both have to happen inside of this parentheses. So now, these three terms should just factor as a perfect square. So we got y equals negative 3, and factors a perfect square, so I should get an x and then something squared, and that minus 121 over 9 should still be outside, and the minus 7 is still there. But what number goes here? This one's a little bit tricky if you just try to do it by factoring this, although it is doable. But it might be helpful to recall the shortcut from the last video of, how do we know what number goes here? So remember, the shortcut is the number that goes there is always what you get when you divided this term by 2. And when we did that, we ended up with negative 11 over 3. So let me just color that in black so it shows up a little bit darker. Negative 11 over 3. So that is what goes here, negative 11 over 3. I'm also going to highlight that in blue. And if we were to check this, if we were to FOIL this out, it should match up and give me these three terms. All right. So next, You know, I got that negative 3 in front. Let's distribute it to the perfect square, and let's distribute it to this fractional term. So doing that, we get y equals negative 3 times that perfect square, x minus 11 squared, and then it's a negative 3 times negative 121 over 9, and then minus 7 at the end. Okay, so I should simplify this constant at the end. So let's see, the 3 and the 9 will cancel a little bit. I can divide each of them by 3. That'll leave me with a 1 there and a 3 down here. The double negative becomes a positive, so positive 121 over 3. And let's get a common denominator with a 7, so minus 21 over 3. And now subtracting, I get 100 over 3. Okay, so we are left with y equals negative 3 parentheses x minus 11 over 3 quantity squared, and we got plus 100 over 3 at the end. So now we completed the square. We got this thing in vertex form. Awesome. So we are ready to write the coordinates of the vertex. So remember, the x coordinate is whatever I plug in for the x to make the perfect square part become 0. So I would plug in positive 11 over 3. And if I do let x be that value, then, well, what's y? Well, the first part is 0, and then I get plus 100 over 3. So that would be 100 over 3. Y would be 100 over 3. All right, so I got my vertex. I'm going to need my intercept so I can draw an accurate picture. So let's get the y-intercept first. When I find the y-intercept, I set x equal to 0. So I could either do that in the completed the square form, or I could do that in the original. I think it's going to be a little bit easier to do it in the original, a little bit less simplification to do. So let's plug in negative 3 times 0 squared plus 22 times 0, and then minus 7. Well, that just equals negative 7. So my y-intercept as a point is 0, negative 7. All right, let's get the x-intercept. The x-intercept. For this, I set my y value equal to 0. And we've mentioned in the last couple of videos that usually the algebra is going to be easier to do if we do that in the completed the square form. Okay, so if I do that, I get 0 equals 3 times x minus 11 over 3 squared plus 100 over 3. Okay, I could do that in the original as well, and if I'm lucky, it'll factor. But often, you know, if I plug in 0 for the y in the original, I'll have to do some quadratic formula. Okay, so now let's solve this. Oh, and whoops, sorry. I think I forgot to put the negative sign in front of the 3, right? Because that negative sign was there. Okay, all right, so let's rearrange this. Let's move this negative 3 thing to the other side. That'll make it a positive. So positive 3 x minus 11 over 3 squared equals 100 over 3. Now I can divide the 3 to this side. So that'll give me x minus 11 over 3 squared. If I divide 3, I get 100 over 9. Okay, now to get rid of the square, I can square root both sides. So that'll give me x minus 11 over 3. And then I get square rooting, I get 10 over 3. And I got to put a plus or minus because I square rooted both sides. So there's two possibilities. Either x minus 11 over 3 equals the positive 10/3, or x minus 11/3 will equal negative 10/3. Okay, let's isolate x. If I add 11 over 3, I get 21 over 3 here, which is 7. And the other one, I get x equals just 1/3. Okay, so relatively nice values. All right, so my x-intercepts are 7, 0, and 1/3, 0. For this problem, it turns out that if we had set y equal to 0 in the original equation, it would have been just fine, because it turns out it does factor. Okay. All righty. Okay, so now I'm going to take all this info and let's draw the graph of y equals negative 3x squared plus 22x minus 7. So without the absolute values, let's draw that graph. So let's start with the vertex. We know the vertex, both coordinates are positive. So maybe somewhere here, 11/3, comma 100/3. And I know it's a downward facing parabola, and there are these two x-intercepts. So one of the x-intercepts is 1/3, comma 0. One of them is 7, comma 0. So if I draw a downward facing parabola, okay, downward facing parabola. This had a y-intercept, which was what? It was -7. It was -7. So in my graph, that looks somewhere here-ish. So 0, comma -7. Again, it's totally not to scale, but maybe something like this for that original graph. So now I want to use this to draw the graph of the absolute value of the whole thing. Absolute value of -3x² plus 22x minus 7. And we saw in the first video of the section what happens when you take the absolute value of a function, like what happens to its graph. Because the absolute value is going to, take any number here that ends up being negative and turning it positive. But if this whole thing was positive, it would just keep it as it is. So what that means is for the parts of the graph like this, where the y values are positive, they just stay as they are. Absolute value doesn't change them. But if there's a part of the graph where the y values are negative, the y values turn positive, and that will kind of flip that part of the graph up. Okay, so let's start by drawing the part that stays the same. Oh, whoops, sorry. All right, so let me start by drawing the part that stays the same. So this part from 1/3, that x-intercept is 7, comma 0. This whole part of the middle, including the vertex at 11/3, comma 100/3, well, that just stays the same. And now the other stuff gets erased. I'm erasing the stuff that is below the x-axis, and then I'm going to reflect it so that those y values turn positive. Okay, so that means that's going to happen to this part and to this part. Those all have negative y values. I'm going to flip those up to make them positive y values. So it'll look like this over here. It'll look something like this over here. Okay, sorry. That second part, let me draw it better. I didn't draw that part of the graph super well. Okay, and now let me label this new y-intercept, which is 0, comma 7. All right, and that is my final graph. So I'm going to box that because that is the answer that it wanted here, that graph.